Hello student, I am Dr. S.L. Munde, Assistant Professor, Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in a previous lecture, we have seen some basic definitions of the game theory. Now in this lecture, we will see next point, that is the payoff matrix in a game theory. What is the payoff matrix in a game theory? Okay. So before going to start, we will see the definition of the payoff matrix. Okay. So how will you define the payoff matrix in game theory? When the players select their particular strategies, the payoff means the points of the player A, gain or losses. Okay. The payoff means gain or losses can be represented in the form of the matrix called as the payoff matrix. Okay. The losses and gain or gain and losses of the players are shown in the form of the matrix. So that matrix is called as a payoff matrix. That means the entries, positive entries, gain and losses entry can be shown in the matrix, and that matrix is called as a payoff matrix. So for the examples, so let us we take the examples. Let a player A have M courses, that means M techniques or M strategy of action A1, A2, AM, and player B. Suppose there are player A and player B, and player B have N strategies B1, B2, Bn. Here it is assumed that each player has his choices from the amongst the pure strategies. Okay, so both player here have their own choices. Okay, then the game can be described by a pair of the matrices, which can be constructed as a described as below. Okay, so in this following way, the payoff matrix can be designed for a player A and for player B. So what are the rules to design a payoff matrix? Row designations for each matrix are the courses of actions available to players B. Okay, so here row are the actions for the player B. Column designations for each matrix are the courses of the actions available to player B. Okay, and columns are referred to as courses for the player B. The cell entries are the payments to A for the matrix, to B for the others matrix. The cell entry Aij is the payment to A in A of matrix, P of matrix, when A chooses the courses of them and B chooses the courses of the action J, action A, I and action J. Next is in a two-person zero-sum game, the cell entries in a B P of matrix will be negative of the corresponding cell entries in A P of matrix. So therefore the A is called maximizing player, B would be try to maximize his gain, while player B is called minimizing player, as the would be try to minimize his losses. Okay, so that means we can say that both players will try to maximize his gain and minimize his losses. Okay, so it is assumed that player A is always a gainer and player B is always a loser. That is all. That is all payoff are assumed in the uh, in try in the player of A. Then the payoff matrix for the player A is given back. Okay, so this is the player A. These are the technique or strategy of player A, and this is the player B. So these are the technique or strategy for player B. B1, B2, Bn. So these are the actions for the player B. A1, A2, A. These are the actions for the player A. And the payoff matrix to the player B is given as player A1 A2 AN, and player B is B1 B2 BN. Okay, minus A11 minus A12 minus 1N. Okay, so these are the positive gainer of the player A, and these are the negative losses of the gainer B. Negative losses of the addition of the both must be equal to the 0. Thus, the sum of the payoff matrix A and B is a null matrix. If you take the sum of these two matrices, you will get the null matrix, means 0. Here the objective is to determine the optimum strategies of both the players that result in the payoff matrix to each, irrespective of the strategy used by the others. Okay, that means we can say that the result of the strategies, gain and losses of the both persons must be the 0. Hence, we shall usually omit B payoff matrix, keeping in mind that it is just the negative of A payoff matrix. Okay. To explain the above concept, let us consider the following example. Okay. Consider a two persons coin tossing games. Each player tosses an unbiased coin simultaneously. Player B plays pays rupees 7 to A. Okay. If head head, if the toss is head head occurs, and rupees 4 if the telltale occurs. Otherwise, player A pays rupees 3 to B. Okay. This two-person game is a zero-sum game, since the winning of the two players are the losses for the other. Each player has the choices from among the two pure strategies, head and tail. Okay, so each and every person has a own technique and own choices. Okay, if we agree conventionally to express of the outcome of the game in terms of the payoff to the players only say A1, then the above information is the following payoff matrix in terms of the payoff to the player A. Okay, so the above information can be written in the following payoff matrix. Okay, so clear the entries in B payoff matrix will be just the negative of the corresponding entries in A payoff matrix. Okay, that means here we can say that the entries of the entries of the player A must be the negative of the entries of the player B. Okay, we generally display the payoff matrix that player who has indicates on the left side of the matrix, and this is the A place the matrix may be the displayed as below. So this is the player A and player B. Okay, suppose there is a head, so player A give the 7 rupees to player B. Okay, we have taken here, if player B pays rupees 7 to A, if there is a head. Okay, suppose there is a head, then player B pays the rupees 7 to A. Okay, so here head, then this player B pays the rupees to player A. That means the player A here gain the 7 rupees. Suppose there is a head and tail, then player A lost the rupees 3. That means player A will give the 3 rupees to player B. Okay, if suppose there is a head and tail, occurs the player A RS 3 to B. Okay. Suppose there is a tail and head, then player A will give the 3 rupees to player B. And suppose there is a tail, then player B gives the 4 rupees to player A. Okay, this is the gain of the player A, and this is the loss of the player A. Okay, So that means we can say that the number of the gains of the player A equal to the number of the losses of the player B, and the addition of both gain and losses must be equal to 0. So then that types of the games is called as a two-person zero-sum game. Okay, so this is the payoff matrix of the two-person zero-sum game. Okay, so in this way we can design payoff matrix for the coin toss, head head, tail tail, and head and tail, tail and head. Okay. So in next lecture we will see the some mathematical basic problems on this topic, head and tail. Okay, and the probability of the uh, probability of the coin toss. Okay, we will see the in example in next lecture.